up to now, you had three lives. So the life in operator algebras, the one with Siegel with Gelfand on foliations, and the one with Siegel on algebraic topology, let's say. Mm-hmm. And so these are three different fields that are, all three of them are hard. So it's really rare, I mean, to see a mathematician, a woman or a man, going through quickly three fields that are so demanding. So how where did you find the energy? I mean, the time, also because you said that you're doing everything at home. So where did you find the time to absorb the prerequisites for all these, and of course then to contribute originally in some original way to each of these fields?
What I did in operator algebras was, I mean, I didn't have a great depth of knowledge. That was one of the problems, that I solved a problem, but it was from a rather superficial viewpoint, and I didn't know where the field led. So I don't think I mean, that was one of the reasons I was so willing to switch fields when I got to Moscow, because I didn't have a depth of vision in that field. And the person, my thesis supervisor, even though he was up to date and could show me recent research, didn't have that depth of vision either, so it hadn't been communicated to me. And with I don't think I did much in foliations. I did a little bit, but not much. And then with the work with Siegel, you know, most of the ideas were his, though the guiding ideas, they were mostly his. And I did learn some techniques, and I suddenly helped develop, prove a few theorems that actually I was very pleased to discover just a few months ago people are still thinking about, and so they haven't been forgotten. Those ideas that we developed are still being sort of worked on by people about configuration spaces of positive and negative particles and things. When I went to MIT, there was this, Bill Thurston had been there the year before, and there'd been this theorem about well, he'd been talking about amoeba, but he was working with properties to do with the groups of diffeomorphisms and the classifying space for foliations. And that's when I was working on that with Graham, and then we sort of parted company, and I continued working in that field and sort of started making some questions my own, I would say. So it was really at that time, it was an offshoot of that I worked on volume preserving diffeomorphisms. Was probably work that nobody cares about now, but it was sort of, you know, I did it and I was sort of doing something independently, and then I started from volume preserving, well, what's the next thing but symplectic? And so that's what led me to symplectic geometry just about the time that the field was wakening up. So I knew Heffliger from the foliations work, and Heffliger had a student, Ben Yago, who'd written, sort of extended Thurston's work from the volume preserving to the symplectic case, and I read that, and I started doing little things in symplectic geometry, and then, well, the Arnold conjecture was proved for the torus, and, you know, things, and Gromov produced his wonderful paper. I mean, things started livening up. So, you know, I would say, for my mind, the field that I've made most contributions really is symplectic geometry, and that's a very rich field. I haven't really felt any need to leave it because it seems to encompass so much, so to speak.